Alright, second video. Um, this one was on probability. I think it was 4, right? Draw a tree diagram to determine the number of outcomes. The spinner at the right is spun twice. So let's see if I can do this. So if it's spun twice, so we have this spinner and this spinner. So P sign. Oh my God. Let me make it bigger. This one and this one. This is green, this is yellow, this is red, and again, this is green, this is yellow, this is red. So how many outcomes can I have here? 3 different outcomes. How many outcomes can I have here? 3 different outcomes as well. So 3 times 3 would give me 9. So I have to have 9 different things I can have. So imagine this is spinner 1 and this is spinner 2. So on spinner 1, so we want to draw a tree diagram. Tree diagram. So if I spin the first spinner, I can get a green. You can land on green, you can land on yellow, and you can land on red, right? So that's my first spinner. But after I spin my first spinner, and I write a 1 over here, now I gotta spin my second spinner. So with the green that I got on my first one, with that green, I can also get a second green, a yellow, or a red. So I can get green and green, I can get green and yellow, and green and red. Well, with my yellow one, let's say it lands on yellow in the first one. Well, if it lands on the yellow in the first one, I can get yellow and green, yellow and yellow, yellow and red. So I can get yellow and green, yellow and yellow, yellow and red. And the last one, I can get, so if it lands on red, I can get green in the second one, or a yellow in the second one, or a red in the second one. So I can get a red and green, red and yellow, and red and red. So if you count them off, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Exactly what we needed. 5. What's the probability that both spins will land in red? Oops, I should have erased that. So what is the probability? So if these are all the possible outcomes, the probability of both spinning landing on red, so if you look at it, there is a 1 chance out of how many? 9. So there's a 1 in 9 chance on landing on red. What's the probability that the 2 spins will land on different colors? Well, different colors will be this one, they're different. This one, they're different. This one, they're different. Yellow and red. Yellow and green is different. Green and red, and green and yellow. So all those 1, 2, 3, 4, 5 are different colors. The other one is green and green, so it doesn't count. Yellow and yellow doesn't count, and red doesn't count. So I have a 5 out of 9 chance of landing on yellow, on a different color. Food. A pizza parlor has regular, deep dish, and thin crust. So we're talking about crust, right? So on the crust, I have regular, deep dish, and 3. So there's 3 different types of crust. Cheeses, 2 different types of cheeses. So my second option here is cheeses, and there's 2 different types of cheese. And then my last one is toppings. There are 4 different toppings I can choose from. So if I were to choose 1 crust, 1 cheese, and 1 topping, right? 1 from each. How many different types of pies or pizza pies can we order? Well, 3 times 2 is 6. 6 times 4 is 24. So we could possibly make 24 different pies. Social Security numbers made up of 1, 2, 3 numbers, then 2 numbers in the middle, and 1, 2, 3, 4 numbers at the end. These first 3 tells you what part of the country you're from. Next 2 tell you what year and what state that Social Security comes from. And the last one, it's really about you, the last 4 digits. So the last 4 digits are randomly assigned, right? And mine, for example, like I was telling some of you in class, is 2666, and you can definitely tell numbers can be repeated. So in the first spot there are 10 different choices, 10 different choices in the second, 10 different choices in the third, and 10 different choices in the fourth. So possibilities, 10 times 10 times 10 times 10 is going to be 10,000 different combinations here in the last 4 in the last group there of 4 digits. How many possible ways can the last 4 digits be assigned? Well, this last 4 digits here, there are 10,000 different ways of arranging that number. Actually, it would have been 9,999. Right? Yeah. Draw T. Draw T. Why do I keep tree diagram? What happens when you throw a penny, nickel, and a dime? It doesn't matter if it's a penny. It could have been a penny, 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 nickel, nickel, nickel. So here is, I'm going to write first coin, second coin, and third coin. And you need to get proficient in this. So the first coin, what can happen? I can get a heads, and I can get a tails, right? And then I throw in the second coin. I can have a heads, and I can have a heads here too. And the second coin can be a tails. Is that first coin, right? Is that first heads. And then if I throw the third coin, with this, so if I have a heads in the first, heads in the second, and then I throw the third coin, what are the two things that can happen? I can get a heads, or I can get a tails. We're going to repeat that with the other ones. So on the first coin, I get a heads, and then the second coin, I get tails, and that means the last coin, I get heads, tail. And do the same thing to the bottom. First coin's a tails, which means the second coin can be a heads or tail. And then which means the third coin could be heads or tail with that first heads, and heads or tail with that second heads. So if you were to write this, you can get heads, heads, heads. You can get heads, heads, tail. You can get heads, tail, heads, heads, tail, heads, heads, tail, tail. At the bottom, you can get tail. Oh, I'm not going to have room, so I'm going to write over here. You can get tail, heads, heads. You can get tail, heads, tail. Then you can have tail, tail, heads. And you can have tail, tail, tail. That gives you 1, 2, 3, 4, 5, 6, 7, 8. So think about it. If you throw a coin, one coin, first coin, you have 2 possible outcomes. If you throw the second coin, there's 2 different other outcomes that can have. Not different, but 2 outcomes. And if you throw the last coin, there are 2 different outcomes that can happen. So if you multiply 2 times 2 times 2, you get 8. And that's exactly what we got. A number cube is rolled and a penny is tossed. Okay. So if you throw a die, possibilities are 1, you can get a 2, you can get 3, 4, 5, and a 6. Yeah. So if he lands on 1, what can happen when you throw the coin up here? You can get a heads or tail. So you can get a 1 with a heads and a 1 with a tail. You can get a 2 with a heads, 2 with tail, 3 with heads, 3 with tails, 4 with heads, 4 with tails, 5 with heads, or 5 with tails, and the 6 with heads and 6 with tails. So again, 12 different outcomes that can happen. 1H, 1T, 2H, 2T, 3H, 3T, 4H, 4T, 5H, 5T, and the number 6 was a heads, and the number 6 was tails. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different outcomes that can happen when you throw a cube, a number cube, and a penny. Remember, a number cube has 6 different outcomes. A coin has 2 different outcomes, and if you multiply, that's 12, and it matches what we have. Sweatshirt, small, medium, large, extra large, and it comes white or red. So all the different possible combinations. So if you walk into a store, you can buy a small, medium, large, and I'm just going to write extra large. And with the small, if you were to buy a small shirt, you have a choice of white or red. Medium, white, medium red, large white, large red, white, red. So you have 1, 2, 3, 4, 5, 6, 7. So you can have small and white, small and red, medium and white, medium and red, large and white, large and red, extra large and white, and extra large and red. 1, 2, 3, 4, 5, 6, 7, 8. You should always write this one. Not just this, the tree diagram, but you should always list out your options. Because from here, I will probably ask, so what's the probability of someone walking a store and buying a small t-shirt? Well, regardless of color, the probability of buying 2 t-shirts is how many small t-shirts are here. Well, 2 out of the how many different combinations we can make? 1, 2, 3, 4, 5, 6, 7, 8. So there's 2 out of a possibility that somebody walking into a store can buy a small t-shirt. And I can make so many other questions like what's the probability of a t-shirt being of white color? Well, there are one t-shirt is white, another t-shirt that's white, 3 t-shirts that's white, 4 t-shirts that are white. 4 out of 8. 1, 2, 3, 4. Yep. Okay, so that's that. Sweet Treats Shop has 5 flavors of ice cream, 3 flavors of ice cream. Chocolate. So I'm gonna go like chocolate. It has vanilla and it has strawberry. And 2 types of cones. So you can get chocolate with regular or sugar cone. You can get a vanilla with regular or sugar cone. And you can get a strawberry with regular or sugar cone. And you have 6 different ice creams. Chocolate regular, chocolate sugar, vanilla regular, vanilla sugar, strawberry regular, strawberry whatever this is, sugar. 1, 2, 3, 4, 5, 6. Okay. Simple enough. Fundamental, this one is easy. What's the probability? No, you want to find a number of possible outcomes. The day of the week is picked at random and a number cube is rolled. Well, there are 7 days in a week and a number cube is rolled, has 6 sides or 6 faces. So just 42 different combinations that you can have. You can have like Monday and 1, Monday and 2, Monday and 3, and so forth. So a total of 42. A number cube is rolled 3 times. Well, if you, on the first cube, there's 6 different possibilities. On the second cube, there's 6 again. And on the third one, there's 6 again. So 6 times 6 is 36, and 36 times 6 equals, I have no idea, 216. So 216 different combination. You can have a 111, a 123, a 155, a 118, not 8, 114. So again, 216 possible things that can happen. There are 5 true, false questions on the quiz. So again, question 1, question 2, question 3, question 4, question 5. On question 1, how many choices you have? Well, it's either true or false, so you have 2 choices. Question 2, true or false, you have 2 choices. Question 3, you have 2 choices, true or false. Question 4, again, you have 2 choices, true or false. And question 5, what could you have done? You could have chosen true or false, so you had 2 choices. 2 times 2 times 2 times 2 times 2 is 2, 4, 8, 16, 32. 32 different ways you could have bubbled in that Scantron, okay, if it was a true-false Scantron, okay. 16, there are 4 choices for 5 multiple choice questions on a science quiz. That's no different, so let me make that 1, 2, 3, 4, 5. So question 1, you had 4 choices, so there are 4 different things that you could have happened. Second question, again, 4 different things. Third question, 4 different choices. Fourth question, 4 different outcomes. And fifth question, you could have chosen 4 different, outcomes, A, B, C, or D. So you multiply all those, 4 times 4 times 4 times 4 times 4 equals 1,024. So we could have bubbled in 1,024 different Scantrons, and they would have been each unique and different than the other ones. Okay? Are you done? Yes. Oh, there's a second page. Okay. So, draw T, so each of the spinners at the right spun one. So we're spinning this and this. Okay. Draw a tree diagram to determine the number of outcomes. So how many outcomes? Well, we can use the fundamental counting principle. Well, there's 4 choices here, 3 choices, so we have a total of 12. But if they're asking us to draw a tree diagram, so let's just draw it. So on the first spinner, you can get a green, or a blue, or a red, or a yellow. That's what can happen on the second spin. And then if you get a green and you spin this one, the second one, the bottom one, with that green, 3 things can happen. You could get green and red, green and white, green and blue, right? And likewise, the same thing. You could have gotten a blue on top, on the first spinner, and then with the second spinner, you're going to get either red, or white, or blue. Or if you got a red in the first spinner, you can get a red again, or a white, or a red. And the last spinner, if you happen to get a yellow on the first spinner, you could get a yellow with a red, a yellow with a blue, and a yellow with a white. What's the probability that both spinners land on the same color? Well, do we have anything on the same color? So I will actually write this out. So I can get a green and a red, green and a white, green and a blue. I can get a blue with a red, blue with a white, and blue with a blue. And then I can get a red on here. Red with a red, red with a white, and red, white, and this should be blue, by the way. Red and a blue. And finally, I could have gotten a yellow here on the first one, a yellow, and then with a red, a yellow with a white, or yellow with a blue. So based on this, what's the probability that the both spinners land on the same color? Is there the same color here? Blue, blue, that's 1. Red, red, that's 2. 2. Of all these, only 2 of them are same color, so it'll be 2 out of 12, or 1 out of 6. What's the probability that at least one spinner lands on blue? Well, there's 1 here. 1, 2, 3, 4. 5 of them had a blue on it. 5 out of 12 for number 19. And what's the probability that at least one spinner lands on yellow? Well, yellow would be 3 of these, right? The bottom 3, 1, 2, 3. So 3 of them have a yellow, so it'd be 3 out of 12, or 1/4 of the time. What's the probability of winning a lottery game where the winning number is made up of 5 digits from 0 to 9 chosen at random? So 1, 2, 3, 4, 5. So imagine if you had to pick any 5 numbers, and you could have, like, I don't know, 0, 0, 2, 3, 7, 8, 2, 0, 0, 9. So I mean, they're made up of 5 numbers, right? So what's the probability of you picking the winning number if a 5-digit number was selected, right? So on the first space here, I had 10 different choices. On the second space, 10 different choices. On the third space, 10. On the fourth, 10, and on the last, 10, assuming that can be repeated. So 1, 2, multiply that out, and you have 5 zeros. 2, 3, 4, 5. Oops. 1, 2, 3, 4, 5. You had 100,000 choices. So the probability of you winning would be 1 out of 100,000, which is better than the Mega Millions Powerball I showed you guys on Friday. 20-something, 2. Dolly can take 4 different classes first period, 3 different classes second period, and 5 different. So first period, she can choose from 4 different classes. Second period, she can choose from 3 different classes. And then the third period, she can choose from 5 different classes. How many different schedules can she have? Well, when you get to college, you will probably get something like this. So 4 times 3 is 12. 12 times 5 is 60. So you can make 60 different schedules. Okay. That's it. And 23. I think we're going to stop at 23. I don't know. Ohio celebrated its bicentennial in 2003. The state issued bicentennial licenses with 2 letters. So the first 2 were letters, followed by 2 numbers. So I'm going to write letters over here. Letters. These 2 are numbers. And then the last 2 are letters again. And how many license plates can be issued? Now you're going to ask me, can the numbers be repeated? I'm going to say yes. And the numbers can also be repeated. Okay. So assuming that's true, we can, the first spot here, you can pick from 26 different letters. The second spot, we can pick from 26 different letters. Numbers from 0 to 9. So we have 10 choices over here and 10 choices over here. And back in the last 2 spots, 26 different choices again and 26 different choices. So this is going to be quite a big number, I'm going to say. So if you were the person making these license plates, or hopefully the company, you would be able to make 26 times 26 times 26 times 26 times 100 equal as 45,697,600 different license plates you will be able to make. Okay. And are we doing 24? If X coins are thrown, write an algebraic expression for the number of possible coins. So if you throw one coin, there are two possible outcomes. Right? If you throw two coins in the air, there'll be four different outcomes. Right? If you throw three different coins in the air, you can have 8 different outcomes. So if you throw X, so if you see a pattern over here, it's going to be 2 to the third, 2 to the second, 2 to the first, and to be 2 to the X power. That would be. So if you throw 100 coins in the air, the number of the total number of things that can happen, you know, you can have heads, 99 times, and the last one tails. That'd be one possible combination out of 100 coins. So it'd be, but if you wanted to find out all the different outcomes, it'd be 2 to the number of times, number of coins that are being tossed, in this case 100, so 2 to the 100. Okay, but the answer here is 2 to the exponent of x, and where x represents the number of coins that are being tossed. Okay, and that's that.